Today we're going to continue our conversation about combining like terms, but we're going to change it up a little and talk about adding linear expressions. So in today's lesson we're going to be adding linear expressions. Linear is a term that we have not talked about a lot this year, but it is something that we're going to talk about a little bit later this year and a lot next year in pre-algebra. So linear expressions are expressions that have the variable x in them taken to no powers. So that's a summary of what a linear expression might look like. It might look like x plus 2, x 3x plus 4, negative 2x plus 8. Any of these things are considered linear expressions. So today we're going to be adding them, or in other words, we're going to be combining like terms once again. So a linear expression is an algebraic expression, here's your vocabulary, in which the variable is raised to the first power, meaning there's no power that it's taken to other than 1. The table below gives some examples of expressions that are linear and some examples of expressions that are not linear. You can add linear expressions with or without models. Sometimes you will need to use zero pairs. Now, if I take a look at my linear expression side of this table, notice how the x term is never taken to any power other than 1, and we know that 5x is the same thing as 5x taken to the first power, but we do not need to write that 1 because we know anything taken to the first power is itself. These guys are considered nonlinear because, as you can see, x is taken to powers higher than 1. Okay, so let's get into our examples. So the first example we're going to look at actually looks at using models to do these problems. However, when we do our problems, we're going to use some of what we did the last couple of days, which was to combine our like terms by adding the coefficients of the variables. But this takes it and puts it into picture form for you. So if I'm looking at 2x plus 3 added to x plus 4, that means I'm taking 2x plus 3 and adding it to x plus 4, and 2x plus 3 means you have 2 x's and 3 integers of 1. X plus 4 means you have 1x, 4 integers of 1. When you put those together and you group like things together, you get 3 x's and you get 7 integers of 1. So your final answer is 3x plus 7. So this is how you would do this if you were using models. So if you want to, you can create little slips of paper at home that have x's and 1's on them. I could give you a template at school for you to cut up and use. Feel free to talk to me and see what works for you. But let's take a look at our first problem. So 6x plus 2 plus x minus 3, and this would actually be saying desks, unless you're actually working at a table right now. So 6x plus 2 plus x minus 3. Now, with models, again, you would have 6 x's here and 2 integers of 1, and then you'd have 1x, and you'd actually have 3 integers of negative 1, which you would do with a different color, realizing that a positive and a negative cancel out to make 0. But in our case, we're going to take a look at this in the sense of combining like terms. So I know that my parentheses are actually not needed because I am adding. So I don't have anything other than positive 1 to distribute in, and 1 times anything is itself. So in this case, it's going to be plus x minus 3. So like we did yesterday, I'm going to regroup to put my like terms together. Squiggles go with squiggles and lines go with lines. I'm also going to turn this into an addition problem so that I don't lose that negative sign that's there. So plus minus. So when I regroup, I'm going to get 6x plus x plus 2 plus negative 3. 6x and 1x, that's going to be 7x. 2 and negative 3, that's going to be minus 1, or plus minus 1. Okay? So again, you might have plus minus 1 or 7x minus 1. All right, let's try another example. 4x minus 2 plus the quantity x minus 4. So again, I can break these out of the parentheses, giving me 4x minus 2 plus x minus 4. I'm going to turn it into an addition problem using my keep, change, change, adding the additive inverse. So I'm going to put a plus there and a plus there. So this becomes 4x plus negative 2 plus x plus negative 4. I'm going to regroup my squiggles with my squiggles and my straights with my straights. So I get 4x plus x plus negative 2 plus negative 4. So that's going to give me 4x and 1x is 5x plus negative 2 and negative 4 is negative 6, which you can simplify to say is 5x minus 6. Final answer. Okay? All right, we've got one more example to try. At this point, I would think it would be wise to pause the video and try this on your own. And now let's go over it. So, again, since I'm adding, tomorrow we'll look at when we subtract what it looks like, but since I'm adding, again, the parentheses are not necessary. So I have 3x minus 6 plus negative 2x plus 7. So again, I'm going to come through really quickly and I'm going to keep change right there. So that gives me 3x plus negative 6 plus negative 2x plus 7. Squiggles go with squiggles and straights go with straights. So that gives me 3x plus negative 2x plus negative 6 plus 7. So when I look at these guys right here, 3x and negative 2x add to 1x. And negative 6 plus 7, that's just going to be 1, which I can simplify to just x plus 1. So either one of these is correct, okay? It's just simple notation. We know that the coefficient of 1, we don't necessarily have to write it, so we can write our final answer as x plus 1. All right, so we are ready for the problem of the day. Nice short lesson today. So add these 4 expressions before you come to class tomorrow. We'll go over these first thing. Have a great night.